In this video, we'll try to understand the valid parenthesis problem. So first we'll try to understand what is the problem statement and the intuition behind using stack to solve this problem. Let's get into it. Hey friends, welcome back. If you are new here, my name is Vinay and I am a seasoned software engineer with over 10 years of professional experience, having worked at Amazon, Nvidia and currently working full-time at Microsoft. I enjoy sharing my knowledge with a focus on understanding things at a fundamental level. I hope you learned something new today. Coming back to our problem statement. So what is the valid parenthesis problem? So by this problem statement, what we mean that you are given a string S which consists of multiple types of opening and closing brackets. So like here we can see that there is an opening square bracket, an opening curly bracket, and opening round bracket. And also like multiple types of closing brackets like closing round bracket, closing square bracket, or let's say even a curly closing bracket. Okay, so given this type of string, so we need to check whether a given string is valid parenthesis expression or not. So what do we mean by a valid parenthesis expression? So every closing bracket should have an opening bracket of the same type. Okay, so this is the first condition. So if we take this example, so here we can see that every closing bracket, like the round bracket here, has an opening bracket which is also of the same type. Similarly, in this expression also we can see every closing bracket, like these two closing brackets, have the corresponding opening brackets. Okay. The second condition that is there, it should also be in the same order. So what do we mean by the same order? So in this expression, here we see that the first opening bracket is a square opening bracket and the second opening bracket is a round opening bracket. Okay, so as the round bracket is open last, so we have to follow it by the closing bracket which is of the same type. So a round bracket should be followed, round closing bracket should be followed after the round opening bracket. Okay, and also since the square bracket was opened first, so it should be opened here, it should be closed here last. Okay, so that is what we mean by the same order. So if this order is not followed, like in this last example here, so here we can see that we have a opening square bracket and opening round bracket, but after this opening round bracket we should have an closing round bracket, but we have a closing square bracket. So the order of opening and closing brackets is not correct here. So this is not a valid parenthesis expression. So given such an expression of opening and closing brackets, we need to tell whether the given expression is a valid parenthesis expression or not. So now let's look at how we can use stack to solve this problem. So let's take a simple example. So let's say I have an opening square bracket and opening round bracket followed by a closing round bracket and closing square bracket. So as we can see here, this is the first opening bracket. So let's call this first opening bracket. This is the second opening bracket. Okay, and then we follow it by a closing bracket. Okay, so here what we can see that the bracket which was opened last, it should be closed first. Similarly, the bracket which was opened first should be closed last. Okay, so in a way here what we are following is last open bracket should be closed first. Okay, and this is analogous to the last in first out principle of the stack. Okay, so in stack, elements which are pushed last to the stack are the first one to get out of the stack. Okay, so similar analogy is followed here. So the last open bracket should be the one which is closed first. So now how do we actually use stack to solve this problem? So let's see. So what are the rules that we are going to follow is, so first, whenever we have an opening bracket, so what do? We simply push it to the stack. Okay, push to stack. And the second, whenever we encounter a closing bracket, we should have a matching opening bracket at the top of the stack. Okay, so this is our second condition. So we should have a matching opening bracket at the stack top. Okay, so let's try to see this example that we have here, okay, and how this rules can help us. So let's say my string is this here, right? So first character in my string is an opening closing bracket. So according to rule number 1, if there is an opening bracket, I push it to the stack. So I push the opening square bracket to the stack. Similarly, I push the opening round bracket to the stack. Okay. Now I have a closing bracket in my string, right? So since I have a closing bracket in my string, what I can do is, according to our second rule, if I have a closing bracket, the matching opening bracket should be at the top of the stack. So currently my character is a round closing bracket and my stack top is what? A round opening bracket. So these two match. So that's why what I can do, I can pop the element at top of the stack. So if this is true, what should I do? I should pop from the stack. Pop from stack. Okay. I will see what to do if this is false. Okay. I will build up. So now since this is true, what I can do, I can simply pop this from the stack. Okay. So now moving on to the last character in the string. So the last character is what? A closing square bracket. Similarly, here what do we see? Since it's a closing bracket, I should have a matching opening bracket at the stack top. So since these two match, so what I can do, I can simply pop from the stack. Okay. So this goes away, this goes away. Okay. So at the end, what do I see? So third condition is what? Stack is empty at the end, and string is also exhausted. Okay, so input string is also exhausted. Exhausted meaning all the characters in the string I have traversed. So I was at this character and I popped the opening bracket that was at the stack. So after that there is no character remaining in the string, and that's why my string is exhausted and my stack is also empty. So at the end of the string, if we reach this condition, which is my stack is empty also, then we can say that the parenthesis is valid, or it's a balanced parenthesis. So now let's take a look at another example. Okay, so let's say there was an additional closing bracket here. Okay, so this is an additional closing bracket. So as per our earlier example, we would have added, so if we start from the beginning, we would have added the opening square bracket, opening closing bracket, then we have the closing round bracket and closing square bracket. So the closing round bracket matches the stack top, which is the opening round bracket. So that's why we pop from the stack. Similarly, this closing square bracket matches the stack top here. So that is why we pop this from the stack. But now what happens is there is one more character left in the string, which is this last character, which is the last closing bracket. Okay. So my closing bracket has come, but now what is the case? I don't have a matching opening bracket in the stack, right? So this is not there, and my stack is actually empty. So that is why this second condition, like when we have a closing bracket, we should have a matching opening at the stack top, matching opening bracket at the stack top. So that is why this second condition fails, and that is why this is not a valid parenthesis expression. Let's take a look at another example. So let's say I had an additional opening bracket at the beginning. So let's say my expression was something like this, and this like this. Okay. So this part here is balanced, but this is an extra bracket, opening bracket. So we'll try to see what happens in this case. So as per our rules, so this is my first character here. So I'll push this to the stack, right? So I push an opening square bracket to the stack. My second character is also an opening bracket, so I also push that to the stack. My third character is also an opening bracket, so I also push that to the stack. Now I have a closing bracket. So because of this closing bracket, what I will do? I will check whether this closing bracket matches my stack top, right? So since this is an opening round bracket, and since my current character is closing round bracket, So these two match. So that's why I'll pop from this stack. Okay. Now going further in the string, I have an closing square bracket. So what I'll do, I'll again check whether my stack top matches this closing square bracket. It does. So I'll pop this from the stack. Okay. And now my pointer is here. So what we have reached here is my string is actually exhausted. So there are no more characters remaining in my given input string. Okay. So now, if we look at the condition here, right, at the end, what should we have? We should have the stack empty and my string should also be exhausted. But in this case, my stack is non-empty, right? My stack is what? Non-empty. So that is why again, this is not a balanced parenthesis. So here using stack, we can see that we follow the last in first out principle, which is getting used here. And this principle of the stack also helps us to actually maintain the order of the characters that should have appeared in the original given expression if it were to be a balanced expression. Now let's look at another example where the order is incorrect. Okay, so let's say my expression is something like this is an opening square bracket, opening round bracket, let's say opening curly bracket, closing curly bracket. But here now instead of closing round bracket, let's say I have a closing square bracket, and at the end I have a closing round bracket. So let's see what would happen in this case. So again I will take initially my stack is empty. So my first character is an opening square bracket, so I'll push that to the stack. So this goes to the stack. Similarly, this is an opening bracket, so I'll push that also to the stack. This character is also opening bracket, so it will go to the stack. Right? Now I see that there is a closing curly bracket. So closing curly bracket should match with the opening curly bracket at top of the stack. So this condition is true. So that is why we pop this item from the stack. Now my string pointer is here. Now I see that this is a square bracket, closing square bracket, and my top of the stack is a opening round bracket. So this condition that these two brackets should match is what? False. Okay, so if you come back to our example, so this condition is now false. So in case this condition is false, which means that my closing bracket should match the opening at top of the stack. So this condition is false. So in this case, my parenthesis is imbalanced. Okay. So in this case also, saying this is a closing bracket and here we have an opening round bracket. So I can just return from here that this expression is what? Balanced. So in this way, we can use the principle of last in first out of the stack to solve this problem of valid parenthesis. Now let's look at the code for the same. So in this code, we can see that we have defined a stack which is of type character. So this here is a character array of size 10. Okay. And similarly, as the previous examples, we have a top variable to know where my stack currently points to. So as always, we have a initialize method where it's initializing the stack top to be -1. Similarly, we have isEmpty and isFull functions. So if top is equal to -1, we return true. Otherwise false. Similarly, isFull, if my top reaches size -1, we return true, otherwise false. And push pop are similar as they operate on a stack. So when pushing an item, I get the item as my input to this function and I put it at the top of the stack. If that is successful, I return true. Otherwise, if my stack is full, I return false. Similarly, in the pop method, if my stack is empty, I return false. Otherwise, in my pointer, which is the popped item, I assign the item that is currently at the stack top and I decrement my top. Okay, and I return true. And then this is the top element function, which simply returns the top element in this top element pointer. So this returns the element that is there at the stack top. Similarly, size, display functions are similar previously. So now the main important function here is the isBalanced method. So in this isBalanced method, what do we have? We are given an input string. Okay. So this is a const_char star pointer str. Here we first declare a variable or define a variable of type struct stack, which is stack, and then we initialize it. So this initialize my top to -1. And then what do we do, as we saw in our previous explanations? So we loop until my string is exhausted, right? So until my str of I reaches \0, we loop over that string. Okay. So first we take the current character, which is str of I. So I is beginning from 0. Okay. So our first condition was if an opening bracket is found, I push that to the top of the stack. Okay. So what do? I take that current string or current character in the ch variable and I push that in the stack. Okay. So if this push doesn't succeed, I return false, meaning my stack has overflown. Okay. Otherwise, I don't do anything. Now this was our first case, right? If an opening bracket is found. But if a closing bracket is found, what do? So in case a closing bracket is found, first I need to check for the matching opening bracket, whether that is there at the top of the stack. So I take a character top variable and I pass its address to the pop method. Okay. So if this pop method succeeds, it means my stack wasn't empty and something came out of the stack top. Okay. So, but if my stack itself was empty, it means the current closing bracket that is there, that is not matching to any opening bracket, right? So that is why my function here is returning false. So we have an unmatched closing bracket. So here we encountered a closing bracket, and when we tried to pop from the stack, it returned false, meaning stack was empty, right? So that's why we have an unmatched closing bracket. So there was no opening bracket for this corresponding closing bracket that we found. Okay. But if this check succeeds, that means we don't go inside the self, we come down and we match the top with the expected opening bracket. So if my top is actually not equal to opening round bracket, but my ch was an closing round bracket, it means it didn't match, right? Otherwise, if my character that I got currently in the string was a closing curly bracket, so I should be expecting opening curly bracket at my stack top. So here this is not equal to, so this got mismatched. Or if it was the similar case with a closing square bracket. So if a matching opening bracket is not found for the current ch, which is the current character in my string at the stack top, so then I return again false. So this is what we mean by mismatched brackets. Okay. So after I have iterated all the string, as we saw earlier, if my stack still is non-empty, it means I have to return false. So this isEmpty check should actually return true. So if we look at here, what is my isEmpty check? My stack top should be -1. So it means when I reach the end of the string, meaning when I come out of this loop, so my stack should be empty. Okay. So if stack is empty, my brackets are balanced. Otherwise, my brackets or the parenthesis is balanced. If they are not balanced, or if the brackets don't match, it means my stack was not empty and hence the parenthesis is invalid. Okay. So this is the function that we wrote. So to call this function, we just pass a character string and we call this isBalanced function with that string. Okay. So now let's go ahead and try to execute this. So let's compile. So here we can see this is a valid parenthesis. Now let's try to change it a bit. let's try to do it something like this. Let's see, save it, compile it and run it. So here again we can see this is a valid balanced parenthesis. So now let's say I add an extra opening bracket at the starting, I save it and I can compile and run it. So here I can say this is not a valid balanced parenthesis. Okay. Similarly, if I add an extra closing bracket at the end, trigger the other scenario, and then I compile and run it. So here we can see that when we try to get an item out of the stack, we got a stack underflow, right? And hence my parenthesis was what? Not a valid balanced parenthesis. So this is how you will write the code for checking whether a given parenthesis is balanced or not. So I hope you learned something new today. Thanks for watching.